Okay, I'm going to go through the answer to the problem 5.084 from the homework problems. This is again a problem that you need to find the Thevenin equivalent of the network in the figure below at the terminals A, B. So this here we are going to have only dependent source, and then we want to find the Thevenin equivalent at A, B. Many of you have asked, so when should we apply a current source like 1 millivolt current source or 1 volt voltage source? Because the only way to answer the circuits that only has dependent source is to add a voltage or a current here and find it, and at the end take it out. And I want to tell you that it does not really matter which one you want to add, and I'm going to solve this problem both ways so that you see that it does not really matter. So the first method I'm going to do is I'm going to add a 1 milliampere current source over here, and then I want to find the R Thevenin across A and B, So if I do that, I have nodes over here, node 1 and node 2, but it would be much easier if I take a super node over here to get rid of the 1000 IX dependent source over here. So if I write the KCL for the super node and one KCL and then find the KCL inside the super node, then it would be easier to solve this problem. In order to do that, I write the KCL at supernode. So the KCL at supernode would be V1 minus 0 over 1 and 1 is 2K. So V1 over 2K. And then I have V1 minus 0 over again 2K. So plus V1 over 2K plus then the other part of the supernode is the 0.2, which is V2 minus 0 over 2K plus V2 minus 0, I don't write the 0, over 2K. So this is equal to whatever current is coming in. The current coming in is going to be 1 milliampere. I could write it as minus 1 milliampere equals 0 or equals 1 milliampere. It doesn't matter really. So the other thing so from this I can conclude that if I multiply everything by 2K, I have V1 plus V1 plus V2 is 1 volt. Is 2 volts because I'm multiplying everything by 2K, and then I get that 2V1 plus V2 is equal to 2. So this is one relationship that I have. So the second thing I want to write is the supernode. Inside the supernode I want to see what do I have inside the supernode. So inside the supernode I have V1 minus V2 is equal to 1000 IX. So inside the supernode, I can write this. I can write V1 minus V2 equals 1000 IX. And then what is IX? So IX is this I. IX is V1 minus 0 over 2K. And IX is V1 minus 0 over 2K. So if I put this one in that one, I can conclude that V1 minus V2 is equal to V1 over 2K. So then I can conclude that so if I multiply everything by 2K, then I have 2V1 minus V2 equals to V1, and then it is V1 minus 2V2 is 0. So this is what I can write. So V1 minus 2V1 is equal to 0. This is what I get from here. What I get from here is 2V1 plus V2 is equal to 2. So if I solve these two, I will get, so if I solve 2V1 plus V2 equals 2, V1 minus, so this is V1, minus 2V2 equals 0. If you solve this, you get V1 is equal to 0.4 and V2 is equal to 0.8 volts. So this is all so this is all solving this problem. If I apply a 1 millivolt over here and then I solve it, then I get the V1. Let me double check my answer. Sorry. So V2 is 0.4 and V1 is 0.8. Sorry. Yeah. So if I apply 1 millivolt over here, I find V2 to be 4.4. So V2 is actually the open circuit voltage. So if I want to find the R Thevenin in this case is going to be whatever my voltage is going to be over here over the current that is flowing through it. So it is 0.4 volts over 1 milliampere. So this is like 0.4 kilo ohm, or I can say 400 milliohm. 400 ohm. So this is 400 ohm or 0.4 kilo. Now I want to look at it, if what would have been the case if I had added a 1 volt instead of this 1 milliampere. So if I just make this a positive and a negative, and instead of 1 milliampere I would have put 1 volts over here, then I have to find the I0 that is coming in here, the I0 that is coming in here, and then if I divide the V over I, then I should be able to find it. If I find the I0, then I can find the R Thevenin being V over I. So I0, and then this V is 1 volts basically. So it is 1 over I0. So now let me see if I solve this whole thing with that, what would be the case. So I just write it in front of what I have done over here so that you can just compare. So if I write the KCL again at the supernode, I would write it as, I would just write it in front of it, V1 over 2K plus V1 over 2K. So I'm just repeating whatever is here and then replacing the I0 with the 1 milliampere that I had before. So plus V2 over 2K equals 1 milliampere. Oh, sorry, it is equal to I0, because it is not 1 milliampere here, it is I0. We don't know what it is. But what we know is that 1 volt is now, V2 is now 1 volt. So now at my supernode, I can basically write V2 as 1 volt. So I do not need to write the V2. So if I make it shorter, then I basically can rewrite, reduce that. It would be V1 plus V1 plus, then V2 is going to be 1 volt is equal to 2I0. So then 2V1 is equal to 2I0 minus 1. So this is one relationship that we have. So the second one, I have to write I have to do it through this thing, right? So V1 minus V2 is 1000 Ix, and Ix is going to be V1 over 2K. So I'm writing inside the supernode. I want to see what I should. I mean, when we solve this, I have to write this all again. So for the inside the supernode, the only thing that would be different is that I know what V2 is. So if I rewrite this for my second case, so I have to actually, if I'm solving it, I have to solve this and then I write it from here. So V1 minus V2, so V1 minus 2V2 is equal 0. So the same thing, but now I know what V2 is, because here I said I'm connecting a 1 volt over here, so V2 is 1 volt. So then I say V1 minus 2 volts is going to be 0, then V1 is 2 volts. So if V1 is 2 volts and 2V1 is this, then I can find the I0 from here. So 2V1 is actually 2 volts plus 1, so this minus 1 is going to be plus 1, is going to be 2I0, and so the I0 is going to be 2 plus 1 is 3 over 2 milliampere. Let's double check if you have not made any mistakes. So this is the Ix. Okay, so this is V1 minus 2V2 is equal 0. V1 minus 2V2 is equal 0. So V1 minus 2 is equal 0. So V1 is equal to 2 volts. So we put the 2 volts over here. So the 2 times 2 is 4. Okay, so here is the mistake we made. So 4 plus 1 is 5. 5 is 2 I0, then I0 is going to be 5 over 2. Yeah. So 5 over 2 milliampere is going to be my I0. So if I know my I0 being 5 over 2, so I know my I0. So R Thevenin is going to be what? V over I. So my R Thevenin is going to be V over I. So my V is 1 volt over 5 over 2. So 5 over 2 is going to be, and then this is in milliampere. So milliampere here is 1K. And then 5 over 2, you're going to get again 400 or 0.4K, which is equal to 400 ohms. So you see that you are getting the same thing. So it really does not matter if you are